Today we are going to see SQL and PostgreSQL for beginners. So, why learn SQL? SQL is one of the most sought after technical skills. It is a must if you work with data in order to save them, manipulate them, and link them together. SQL is at the top of the list of jobs in programming, above C#, JavaScript, and even Java. And in the modern era of big data, the demand for SQL will only increase. And why PostgreSQL? Because this is the most advanced open source and adaptable relational database in the world. It is the most popular and the most used database system. PostgreSQL is used by companies such as Netflix, Apple, Spotify, or Instagram. We will be using PostgreSQL in this course, but the SQL language you will learn can be applied to any database system like Oracle or MySQL. At the end of this course, you will be able to create a database from scratch, make complete SQL queries using joins and subqueries, understand complex database concepts such as relationships between tags, conduct data analysis by using SQL, and finally, you will be able to include these qualifications on your resume legitimately. Let's go. Hello. Today we're going to see what a database is. There are two definitions. The first is that a database is a structured compilation of information and data. Here we have an example of an offline database, which is an extract from a cake recipe book index and which can be called a database. Recipes are compiled in this index and are arranged alphabetically. This index is handy if you want to find the page of a specific cake. Here, I would easily find the recipe for a tiramisu on page 21. But that is the only function the index will provide. If I want to see all the recipes containing coffee, or sort the list of recipes by page and not alphabetically, the index becomes useless. This is where the second definition of the database comes in. A database is also a method of accessing and manipulating data. It would then allow us to sort recipes by page and select cakes containing coffee or vanilla. There are various types of databases, such as flat files or text-oriented databases, like Excel spreadsheets. In this case, recipes can be sorted in alphabetical order or by ingredients. There are also document-oriented databases, known as NoSQL, or not only SQL. Most of the time, the documents we use are in XML or JSON format. They are very flexible and extensible, but they also have their downsides. Finally, there are relational databases, which are by far the most popular databases nowadays. If you hear about Oracle, MySQL, or SQL Server, all of them are relational databases. PostgreSQL is also a relational database. So, in our next video, we will talk about what is a relational database and how SQL and PostgreSQL relate to all of this. Hello. In this video, we will see what relational databases and database management are and how SQL fits in this context. In a database, data are stored in tables. Tables are the same as Excel tables. They consist of columns and rows of data that can be linked together according to relationships. These relationships between tables are what will make a database so powerful. They allow us to identify one part of data related to another in the DB. Let's look at an example of a relationship between tables. Here we have a pet table containing some pieces of information about them. We have the ID column to identify each pet, the type of animal, cat, dog, etc., a column with its name, and another with its age. Last, you notice there is a column owner ID. This owner ID column links the data from the pet table to another table in the database. In this context, the other table in the DB is the owner table. It includes data of the pet's owner. We have their last name, first name, age, and city of residence. You can notice the first column is an ID column. The ID column from the owner table is linked to the owner ID column in the pet table. From these two columns, we can match the data and see who owns each pet. This way, we can observe that Moustache the cat has the owner ID 3. This corresponds to Audrey Richard from Lille in the owner table. We can also observe that the owner of Snoopy the dog and Carotte the rabbit is Marion Dujardin with ID 1. We will further explore the subject of relationships in databases later in this course, so please don't worry if it's not completely understood at this stage. When people talk about databases, they usually refer to relational database management systems. Every popular database like MySQL, Oracle, and PostgreSQL is actually a relational database management system, or RDBMS. RDBMSs allow us to interact with relational databases. They provide tools and a graphic interface to interact with the DB. PostgreSQL is the relational database we'll be using in this course. It is the most powerful and most popular database in the world. Now, we need to learn where SQL fits in this environment. SQL means Structured Query Language. It is a language used to interact with relational databases. We can write queries by using SQL to create tables in the database, make inserts and modification, retrieve data, and much more. The SQL syntax is very similar from one database management system to another. Thus, the SQL language we'll be learning in this course won't only apply to PostgreSQL, but may also be used for MySQL, Oracle, and such. Now that we know what database systems, relationships, RDBMSs, and the SQL language are, we will install our database system, PostgreSQL. Hello! In this video, we'll see how to install PostgreSQL for Mac. If you wish to install PostgreSQL for Windows, another video is at your disposal. So let's go on our preferred search engine and search for PostgreSQL. Click on the first link to go to the official website of PostgreSQL. Click on Download. Here are the packaging and installers where you'll be choosing your operating system, which is here Mac OS. There, you have to press Download the installer and pick the latest version. At the present time, it is 13.2 for me. Then choose again the operating system that fits yours and download. The downloading has started. We'll meet again once it's done. Now, let's install PostgreSQL. Press Next and choose the installation folder. We'll leave it this way. You'll need to accept everything. Same here. Choose a password of your choice for PostgreSQL. And here, select your chosen port. Press again Next, then Install. It will take a bit of time, so let's meet again right afterward. And there you go, it's installed. Untick this option for the stack builder, and we're done. Search for pgadmin in your apps, PG being for PostgRE, and open it. PostgreSQL is a very secure platform. It will thus regularly prompt you for your password. You have then access to the dashboard. On the left are the servers, thus PostgreSQL 13 that we just installed. Below are our databases that we'll add afterwards. And the highly graphic dashboard that enables you to graphically see the server's activity. Now we can finally get down to business and create our database. Hello, in this video we'll see how to install PostgreSQL for Windows. If you wish to install PostgreSQL for Mac, another video is at your disposal. First, search for PostgreSQL on your preferred search engine. Go to the official website. Then click on Download. Choose here Windows, click on Download the installer, and pick the latest version for Windows. The downloading begins. We'll meet again afterward. Once installed, launch the software. Click on Next. Click on Next again for the installation directory. Again, do an installation by default. And here, enter a password that you'll be using for PostgreSQL. You'll be prompted for it regularly. You can leave the port this way. Same for this configuration. Click Next. Launch the installation. It takes a bit of time, so here as well. We'll meet again once the installation is complete. Several minutes later, the installation is now complete. Uncheck Stack Builder and finish with the installation. Launch pgadmin, which is for PostgreAdmin. Type your password. And we can finally work with PostgreSQL. Hello, in this video we'll be discussing tables in databases, what they look like and what they consist of. Learn that tables include columns, which can also be called fields, and rows of data. Each column in the table will contain data of a defined type. So, for example, if a column has a numeric type such as integer, then this column will only be able to include a number and cannot contain words or dates. Each row of data must be unique, so there should be no identical rows. Finally, each field can only hold one piece of data, so for example, a column email in a customer database should not contain more than one email per field. Now let's have a look at an example of a table. It's a database table that includes information about a group of French people. There are 5 columns in this table. There is the ID column, a column with the individual's first names, another with their last names, the fourth one with their city of residence, and a column with their home department. Thus, each column has a name, and you can see the data type below. In the next video, we'll see data types in further detail, but we'll only be addressing the subject globally for now. You can see that the ID column has integer as its data type, which means whole number. You can also see that every value is an integer: 1, 2, 3, 4, 5. The following columns have various characters or a varchar data type. It's important to know that these columns can only accept character sequences such as Julien, Brown, not, etc. As said earlier, each field is unique and can only contain one entry. It's important to know that the ID column is particular in the table. The ID column is a primary key. We'll explore the topic of primary keys later in this section, but basically, a primary key uniquely identifies each row of a table. You can see now that the numbers in this column go from 1 to 5. These numbers allow us to identify each row uniquely. So with ID 1, we can identify Julian Brown from Nantes in the Loire-Atlantic region. We have covered the basics of a database table and how it looks. Multiple data tables can be found and linked together in a relational database. We will reserve an entire segment of this course for the relationships between tables, as this is what makes relational databases so powerful. Database tables are linked through primary keys and foreign keys. We'll see what these keys stand for very soon, but for the time being, we will be focusing on what data types are, so check out for the next video. Hello. In this video, we'll be discussing different types of data. There are many types of data in PostgreSQL and every database management system, so we'll only cover the most common and useful ones. The first category of data types is the numeric type. The first type is int or integer. It is undoubtedly the most commonly used type you might encounter in a database. This type is used to store all numbers, so many columns you will find will have an int type like for age or quantities. The second type is numeric. It concerns decimal numbers such as 1.50 for measurement or 90.99 for a price. When applying the numeric type to a column, you must specify two factors. The first is the highest number of digits a field can accept, and the second is the scale, the maximum number of digits allowed after the point. The last data type is serial, which is specific to PostgreSQL. It is not an actual type as it stores an integer, but it will automatically be incremented by 1. So the value in this column will start with 1 and increment automatically. We will often use this type for IDs. The next data type category is strings. The first type is char. It stores strings of fixed length. It can be used for the title, gender, or any acronym. The following type is the most used of the string types, the varchar, which can store strings of various lengths with a maximum of characters defined. It's a data type that stores names, first names, emails, and so on. The last type is text. It is used for strings that have no maximum and are often quite long, such as feedback or product descriptions, for example. Then we have the date category. The first one is time, which stores hours, minutes, and seconds in a 24-hour format. This type of data is not commonly used. The next type is date, in the year, month, day format, so 2001 will stand for the 1st of January 2000. This type is used for birth date or the release date of a film, for example. The last data type is a timestamp, which combines date and time. It can therefore be used, for example, for an order or a delivery. Finally, there are two other commonly used data types. The first type is Boolean, which only stores true and false. It is used, for example, to specify whether an item is in stock or not. The last one is the enum type, which can only store user-defined values. So if you create a list of values, the column will only be able to contain this values choice. For example, you have created a list with the days of the week. The choice then can only be made on these values. If you tried to enter another value like September or spring, you would encounter an error. We have thus covered the main data types in a DB. So let's move on to the next video to discuss primary and foreign keys. Hello! In this video, we'll be discussing primary keys and foreign keys. A primary key is a column that uniquely identifies a row of data in a table. The values in the primary keys column must be unique and cannot be null. There can be no missing data in the primary keys. And there can only be one primary key per table. Primary keys are not mandatory, but it's convenient and highly recommended to have one in each table. Now let's have a look at the primary key column. Here we have the owners table, which contains data about who owns a pet in France. The table has 5 columns: ID, first name, last name, and city of residence. So we need to choose which column will be the primary key. Remember, the primary key must be unique and cannot be null. This table doesn't lack any data, but we still need to consider the unique characters. Using the first name or last name columns wouldn't make sense, because the table could include multiple Marion or people belonging to the Dujardin family. So these values may not be unique. The same applies to age or the city of residence. Therefore, the ID column, which only includes unique values for each row of data, is most suited to be the primary key. Now let's have a look at the foreign keys. Foreign keys are used to link two tables. A foreign key is a column in which the values match the primary key column of another table. So there is a column in one table that relates to the data in the column of another table. It would thus create a relationship between the data of the two tables. The table with the primary key is called the reference or the parent table, and the one with the foreign key is the child table. A table can hold several foreign keys, and it is perfectly normal for a table to have no foreign keys. Let's look now at a table with a foreign key. There is a table of the pets belonging to the owners of the previous table. Again, we have the ID column, which is a key to this table. There is a column for the type of animal, one for its name, one for its age, and the last is called ID owner. Therefore, it is a foreign key that relates to the ID column of the owners table. Have a look at Moustache the cat's row, whose ID owner is 3. If you go back to the owners table, you'll see that Audrey Richard, from Lille and with ID 3, owns Moustache the cat. And if you pick ID 1 here and go back to the pets table, you can see that Marion Dujardin owns Snoopy and Carotte. So this is how we'll link tables together in a relational database, and we'll see how to use these relationships next time in this course. Hello! In this video, we'll discuss unique, not null, and check constraints. These constraints can be applied to a specific column through the database management system. Let's start with the unique constraint. It ensures the values of this column are unique, so no duplicate values can be accepted. Should an identical value be inserted in the DB, an error would occur and the insertion would be denied. When you create the table, you must specify whether the column must contain the constraint or not. For example, each email address is different in this table, to which I have added the email column. To ensure there is no duplicate in this column, you can apply the unique constraint to check the entries so that each email address has only one copy. None of the other columns should have this constraint, since several people may share the same first name or live in the same city. The ID column automatically has the unique constraint. Let us now proceed to the not null constraint. Defining an ID column as a primary key applies the not null constraint. This constraint ensures that no field in the column can be null. So if a data item is fundamental to the table, like the email or the last name, you can apply the not null constraint to the column in question. And just like the unique constraint, you can apply the not null constraint to a column when creating a table. It would be easier to see what we mean by a null field by looking at this table. So in our table, you can see that some of the fields are filled with null, such as Mr. Totu first name or Mr. Cotillard's age. This time, Mr. Totu didn't give his name and Pierre his age. Although it doesn't prevent you from entering data, you wouldn't want to go without the email or the name. Therefore, you must apply the not null constraint in these two columns, meaning these two fields must be filled in. Let's move to the check constraint. You can use this constraint to check whether the entries in a column correspond to a Boolean expression, and thus return true or false. For example, an age column should contain values greater than 0. Then the check constraint will check whether the value entered in this column is greater than 0 or not. Another example. To give a recipe a score, you want to ensure that the score is between 1 and 5. So the check constraint will help to define this. Let's take a closer look at an example of our pets table. Here again is an age column. You wouldn't there to be values below 0. That wouldn't make sense. So you can add a check constraint to this column, which will check that the values are greater than 0. So that's it. We've covered table's main constraints. Let's meet in the next video to create our first table. Hello, now that you have learned everything about databases, such as primary and foreign keys, constraints and data types, you are ready to create the first table of your DB. You're going to create a database with information and data about films and their actors and directors. So you'll have a table for each of them as well as a table to link the movies and actors. We'll talk about it later. Now let's create your first table. First of all, go to the left side with the servers, which is for you PostgreSQL with the corresponding version. Expand it. Below are databases. A Postgre database has already been installed here during the installation, but this is not what you'll be working on. Click on Databases and then do a right-click on Create Database to create your DB. Enter here the name of your database, thus films, and save. You can find here your database films. Click on it. You can see that there are quite a few options that you can work with, but for now, you'll just click on your database to create your table. Rather than clicking on Create like earlier, choose Create Script. It is where you're going to develop your SQL script. You can see here the page for typing your SQL queries. Skip a few lines and let's type here your SQL code. Let's start with the directors table. You need to specify it as a command to structure the code. Then you'll be typing the SQL query. To create a table, type create table. And then enter the table's names. So, directors. Keep it in lowercase to make it easier. Open the brackets. And conclude with a semicolon. Go back in the brackets. Skip a few lines and type in between each column you want to insert into the table. So first, and as you have already seen, it will be the ID. So director ID. It is a primary key, so you need to use a serial type. Remember, the serial type is an integer that automatically increments with each row inserted into the table. Since it is your primary key, apply primary key and add a comma. Go to the following line for the next column. You'll be entering the first name, so the data type that you'll use is varchar for various characters. Remember, you must specify a maximum number of characters for this data type. You will assign it a maximum of 30 characters. Enter the comma to move on to the next column, which will be the director's name. The data type here will also be varchar, and the maximum can also be 30 characters. However, you will apply a not null constraint to it. Keep in mind that the not null condition means that the field cannot be empty. The next column will be the birth date. Thus, the data type will be date. Finally, the last column will be the nationality, that will also set in varchar with a maximum of 20 characters. It should be enough. Since it is our last column, we do not have to add a comma at the end. To create your table, you need to define it and, between brackets, determine the column's names. So, director, first name, last name, birth date, and nationality to which you'll assign a data type. For the first one, it will be serial, then varchar, date, and so on. Of course, you must specify that the ID is a primary key. As for the others, you can assign constraints, like not null for the name. You can now launch the query. Select the script and hit the triangle to execute the SQL query. You can see at the bottom that the request has been successfully processed. You have thus created your first table. To confirm it, you can type select star here, which means all from director. Repeat the process. Launch the query here, and now you can see that your table is present in the DB. You have the first column, director ID, the first name, last name, date of birth, nationality, and the specified data types underneath. Congratulations, you have created your first table. Hello, in this video you will create your actor table. Here are 5 columns to which you have assigned data types. So the first column actor ID has a serial type. The first name column has a varg type of 30 characters maximum. Same thing for the last name. And the title has a card type of 1 character. Basically here, it's a matter of giving the gender, M for male and F for female. Then the date of birth, date. I invite you to take the example of this table and try to create it yourself. Don't forget the primary key. You can therefore pause this video. Otherwise, let's go for the creation of the actors table together. Now let's go back to the films database and the CRUD creation. Type first the command to frame the script, which is thus creation of actors table. Like before, create table and you'll call it actors. Open the brackets and close the query with a semicolon. You should always close SQL queries with a semicolon so that PostgreSQL knows this is your query's end. Go back between the brackets and skip a few rows to insert the column. The first column and, of course, our primary key, actor ID, with the serial type. Add the comma to switch to the next column, the actor's first name. As said earlier, it is a varchar type of 30 characters. Add the comma and the name with also a varchar type and 30 characters. Now the title, which will be a card type of 1 character. Indeed, and as explained earlier, you'll simply need to enter M for male or F for female. And finally, the birth date with the date type. You have finished creating your table. As for the directors table, select the query and launch it. Again, you have successfully completed the request. To confirm it, repeat the steps you did earlier. Select all from actors. Select, launch, and find the actors table in your DB with each of the columns you have inserted. Well done if you have managed to do this on your own without this correction. I just have to specify that the column names of your table and the data types must be the same as mine, because later on you will add data to this table. Therefore, the title and types must be the same as mine. Otherwise, the requests won't work. However, if you did not do as I did, you will have to delete your table. To do this, go back to your script and type drop table. Be sure to put the name of the table. Otherwise, it might result in conflicts and the loss of all of your work. Then launch the query just as you have learned. Once deleted, you can create a new table precisely as you did just now. That's it for this video. So see you next time to make our film table. Hello, in this video you will once again edit existing tables. More specifically, you will change the data type of a column. To do so, you need to use a SQL query. For example, you'll change the nationality columns type in your example table. To edit your table, let's start with the SQL query alter table. Then add the name of your table and move to the following line. To now edit the column, type alter column and add the column's name, which is here the nationality. To change the type of data, add type. For the nationality, for example, you could type French, British, or American, or set it to car and restrain it to 2 characters for FR or US. As usual, select the query, launch it, and it will return successfully. To confirm it, type select all from the name of your table, so examples, select, launch the query, and indeed you can see that the nationality data type is therefore character with a maximum of 2 characters. In this case as well, you can change several data types in one query. For example, let's change the maximum number of characters in our varchars. Type again alter table, the name of your table, and alter column to edit the column, which is thus the name. Change its type, so remain in varchar, and for example, set it to 50 characters instead of 30. Use a comma to separate the second query. To edit our email column, type alter column and type again. Remain in varchar, but instead of 50, set 80 characters maximum, for example. Launch the query, select, launch, and successfully returns. To confirm that the columns have been modified, launch the query, select all from examples. You can notice indeed that the name now has 50 characters maximum in varchar and the email 80 characters maximum. So, to edit the data type of a column, you have to start by invoking the table you want to modify, then the column in question, and then changing its type. You have learned how to edit tables, columns, and data types. So let's move on to the next video to learn how to delete tables in a database. Hello, now that you know how to alter tables in your database, the last thing for you to see is how to delete tables in your DB. Let's go back to the test database. To create a new table you will delete afterward. Type create table, which will be called practice. Open the brackets and close with a semicolon. You know the process. You'll add a few columns. The first one will be called ID. It will have a serial type and will be the primary key. The second will be good in varchar. You'll set a maximum of 30 characters to it. Then the third column will be the price, to which you'll set a numeric type with 4 and 2 characters. As usual, execute the query and you have created your table. It is our practice table. It may be simple, but it is sufficient enough for the exercise. First, let's check that your table has been created. Enter the query select all from practice. Select the query, execute it as usual, and you can observe that the table does exist in the database. You will now delete your table. You just need to type drop table and the name of your table. Again, select, execute the query, and it successfully returns. So let's see what happens if you select the query, select all from practice again. Error, relation practice does not exist. The table has been successfully deleted. Therefore, to delete a table, you just need to type drop table with the table's name and execute the query. It's time for a challenge. You will create a database named drivers cars together with its table. So your first task will be to create a new database which will be drivers cars. Then you will create a drivers table with 5 columns for the ID, the last name, the first name, the department, and the license date. The data types are shown in this table. Your next task will be to create a cars table with a foreign key. It will also contain 5 columns: ID, brand, model, year, and foreign key, which is a driver ID. The fourth task will be to add email to the drivers column. There has to be a sixth column, the email column, with a varchar type of up to 50 characters. Finally, you will change the data type of the last name column in the drivers table. You will set a varchar type of 50 characters maximum instead of 30. It's up to you. Here is the solution to the challenge. Select servers, databases, and create database. As agreed, the database is called drivers_cars. Save. Then go to Drivers Cars. Right-click, Create Script, and this is where you'll create your tables. There still are the 4 remaining exercises. There is the creation of the drivers table, so type create table drivers, open the brackets, and add a semicolon as usual. The first column will be ID with a serial type. It will be your primary key. Then you have the last name in varchar 30. The first name with also a varchar and 30 characters maximum. The department will be an integer, int. And finally, license date, which will be a date. Select the query, and it successfully returns. Enter a select all from drivers to confirm the table is created. Indeed, the 5 columns can be found and the drivers table is created. Now let's move on to the next exercise, creating the car table. Type create table cars, open the brackets and add a semicolon. Let's start with the ID column with a serial type and which will also be a primary key. The brand will be a varchar with 30 characters maximum. Same for the model column. The year column is an integer, and the column driver ID, which will be the foreign key, will also be an integer. Type here references to invoke the drivers table and add the corresponding table, ID, between brackets. Select the query to execute it. It successfully returns. Now let's confirm that it is created with a select all from cars. And you can observe that the 5 columns are in the cars table. So let's move on to the next exercise, adding the email column. Enter alter table drivers and add column email. Set it to a varchar type of 50 characters maximum and give it the unique constraint. It was an option, but you've seen a lot of it for emails. Execute the query, check, select all from drivers, execute the query, and you can observe that the email column has indeed been added to the drivers table. Let's now alter the data type of the last name in the drivers table. Therefore, add alter table drivers. Alter column last name and add type to alter its type. Keep it in varchar, but this time set it to 50 characters maximum. Select the query, execute it, and it returns successfully. Check with the select from drivers. Indeed, the name data type has been changed to varchar 50. Well done to you for this challenge. You can find the code attached to this video. Congratulations on completing this section. It was an extensive section with a lot of information. By the way, let's review what you have learned. You have learned about the different data types in PostgreSQL. You have also seen the concept of primary and foreign keys. You have also seen the unique, not null, and check constraints. You have learned to make a database and tables. And you have learned about altering and deleting tables. If you have not managed to create the database or the tables, the code that will allow you to make them will be attached to the video, as you will need them for the rest of this course. See you in the next section. Welcome to this new section about the data manipulation language. It consists of insertion into the DB, modifications, and data deletion. So you will learn how to insert data into a table and edit or update it. Then you'll learn how to delete it. Finally, you'll insert data in the films database you created earlier. So let's get started. Hello, this video, you will learn how to insert data into a table. First off, let's go to the servers and the databases. You'll use the test database to practice in this video and the following ones. So, create a script, which is, as always, where you will start working. Be sure you are in the test.db. Inserting data into a table means entering a SQL code starting with insert into and then the table's name. Between brackets, quote the names of the table's columns. Then add the values and between the brackets, enter the values to insert. Each value will be inserted between quote or double quote, except integer, which will be entered without typographical symbols. So value 1 refers to column 1, value 2 to column 2, and so on. So keep in mind that we have the examples and training tables in the test database. So you will do your first insertion in the examples table. Enter select from examples to have your columns displayed in front of you. Execute the query and you can see the columns example ID, first name, last name, email, nationality, and age. It is in these columns that you will insert the values. Type insert into your table's name, thus examples, and put the column's name between brackets. You can notice that there isn't example ID, because it is a serial that is automatically incremented. Then add your values, the values corresponding to the columns. Add Vanessa Dupont. Add her email address and her nationality. Remember, you said 2 characters, so FR, because Vanessa is French. Then her age, 42. Close with a semicolon, select the query and execute it. The query is successfully executed. Then select the Select All from Examples to confirm the insertion, and you can see that Vanessa has indeed been inserted into the Examples table. Also, you can observe that Example ID has been automatically entered starting with 1. Therefore, this is how you insert data into a table. You can also add multiple rows in a single SQL query by separating the values in each row with a comma. You will be able to test it now. As before, type insert into and the name of the example's name, excluding the example ID 1, which is automatically incremented. Add the values corresponding to each column. So here you're going to add Mike Smith, whose nationality is British. Add his email, nationality, UK, and age, 27. You are going to insert another line. Open the brackets, always between quotes, as these are strings. Add Stella, Cruz, so scruz@gmail.com. For example, her Hispanic name implies her Spanish nationality. She is also 34 years old. Separate with a comma and add another line. Let's say Anka Jurgen. Add the corresponding email to the third column, her German nationality, Deutsch, and her age, 57. Finally, you're going to add the last line. So, John Douglas from the United States, so US, and he's 39 years old. As you can see, each line is separated by a comma and ends with a semicolon. Select the query, execute it, and to confirm, select all from examples, and you can see that each of the stakeholders is inserted in your example table. So to summarize how to insert data into a table, you need to type the SQL code insert into and then indicate the name of each column. Exclude the ID column, which has been set as a serial and is therefore automatically incremented. Type values, and then in brackets, type the value for each column. Simply use quote or double quotes for strings. Integers do not require typographical symbols. Hello, in this video. Hello, in this video you will learn how to modify data in a table. You have the examples table from the test database into which you have inserted data in the previous video. You are now going to modify them, and to do so, here is the SQL query. You have update to specify the table's name to be changed. Then set, which indicates which new value will be applied to which column. And then the where condition allows you to filter the data that meet a specific condition. So update the name of your table, set the column's name equals, between quote or double quote, the new value. Then the condition where, with the column's name, then the value between quote or double quote, allowing to filter the fields to be modified. So let's apply this to Mike's nationality, originally from Britain, so GB, which will change to US. So update the name of your examples table, set the name of your nationality column, then your new value, here US, between quotes, and where, which is your condition, example ID, with Mike's ID, which is 2. Indeed, you will use the ID in your where condition, as it is the safest indicator as a marker since the primary key is unique. Select and execute the request. As usual, enter select all from your examples tables to confirm it. Execute the query. Mike has switched nationality from UK to US. You can also notice that the row went last in the table, but Mike's ID did not change. You can also change multiple rows of data in a single SQL query, but this time without using the primary key. For example, modify Mike and John's nationality, who are not American but ultimately Canadian. So update your examples table, set nationality, put the new value between quotes CA. Your where condition, nationality, is here, US, which is the value to change. Select and execute the query. Let's confirm with select all from examples. Indeed, John and Mike have become Canadian. Finally, you can also edit multiple fields of a single row in a single SQL query. For example, let's change Anka's first name to Anke and her age to 37. Type update the table's name, so examples. Set the first name, so her real name Anke, and add a comma to separate the SQL queries. Assign her age 37, but not between quotes since it is an integer. Where example underscore ID equals 4, since this modification only concerns Anka, whose ID is 4. Select the query, execute it, and verify that the change has been applied. And indeed, Anke has regained her first name and actual age. So this is how you modify data in a table. Start with update to specify which table to modify, set to indicate which new value will be applied to which column, then the where condition, which will filter out data that meets a specific condition. Now let's meet in the next video, where we will see how to delete data from a table. Hello, in this video you will see how to delete data from a table. To do so, the SQL query starts with delete. Then indicate the name of the relevant table, then the where condition. Enter the name of the marker column, and finally its value. Let's put this into practice. Suppose you want to remove Vanessa Dupont from your table. You can execute this query using the ID. So delete from examples. Where example ID equals 1, since Vanessa's ID is 1. Select the query, execute it, and it returns successfully. To confirm, enter select all from examples. And you can observe that Vanessa has been deleted from the examples table. You can also delete several lines at the same time, but there must be a common feature between the two lines to do so. Thus, the marker cannot be the primary key. For example, Mike and John are both Canadian, so you can use this data to delete them. So type delete from your examples table, where nationality equals between quotes CA. You can use double quote if you wish, semicolon, execute the query, it returns successfully. Select the select all from examples, and you can see that Mike and John have been removed from your table. Last but not least, you can delete all the data in a single query. To do this, enter delete from examples, the table's name, and that's it. Finally, select the query and it will delete all the data in the table. By the way, check with the select all from examples and you can see that the table is completely emptied of its participant. To summarize, the SQL query to delete data in a table is delete from. Specify the name of the table, the where condition, and in case you only want to delete one row, specify the primary key, the ID column with the ID of the row concerned. However, you must specify the shared values between several rows to delete them. Finally, Simply type delete from and the table's name if you want to empty the table of all of its data. Now we can move on to putting what you have learned into practice by inserting data into our films database. So let's meet in the next video. Hello, now that you know how to insert data and change and delete them, you're going to insert data in your films database. You will select the films database and click on Create Script. You can insert your data here. Therefore, several scripts have been attached to this video, so you can insert their data into your tables. Here how it's done. Open the first script. Here are the data for the directors table. Select the Insert into Query with all values. Copy and paste them into PostgreSQL. Select the query. Execute it. You can see it was successfully executed. To check, enter Select All from Directors. Execute the query, and you can see that all directors are listed in the Directors table. Open the next script. Here are the data for the Actors table. Select the Insert into Query with all values. Copy and paste them into PostgreSQL. Select the query. Then execute it. And you can see it was successfully executed. To check, enter Select All from Actors. And you can see that all actors are listed in the Actors table. Again, open the next script. Here are the data for the Films table. Select the Insert into Query with all values. Copy and paste them into PostgreSQL. Select the query and execute it. Again, the query has been successfully executed. Enter Select All from the Films table to confirm the films have been inserted. And indeed, all the films are listed in the Films table. For the last script, you will insert data in the films_actors table, which links films IDs to actors. Open the script. Select the Insert into Query with all values and paste it into PostgreSQL. Select the query, execute it, and you can see it was successfully executed. As usual, type Select All from films_actors. You can observe that all films are linked with the actors in the Films Actors table. So you have all of your data in the Films database. You will use them throughout this course to learn how to manipulate data and use joins, subqueries, and aggregation functions. Now that the Films database is ready, you can proceed to the next step. Now that you know how to insert, modify, and delete a table's data, it's time for a challenge. You will use the driver's cars database you developed in the previous challenge. You will have to insert the drivers of the drivers table. There are 7 rows of data, so I challenge you to do an insert into query to insert this data into the table. The second part consists of inserting this data into the cars table. You will have to insert 6 rows of data into the cars table in the same fashion. Next, you will have to change the Ford Mustang's year to 2010. You can see that the year shown here is 2000. You will therefore have to change it. Finally, you will have to delete Remy Oberty from the drivers table. So now it's up to you. Hello, well done to those who have completed the challenge. In this video, I will guide you step by step to solve this challenge. As specified in the challenge video, you will work on the drivers underscore card database. So go to Databases and choose the drivers cars database. Right-click on Create Script and you will arrive on the script page. Here you will be able to read the 4 pages to be done that were chosen during the video challenge. The first query you will type was not required, but it will allow you to set the date as we do in France. In other words, day, month, year. So type set date style equals quote SQL, European and close with a semicolon. As usual, select the query and execute it. And make sure it has been successfully executed. Now you can move on to your first task, inserting the data into the drivers table. The first thing to do is obviously insert into the name of your table, drivers. Put the name of each field in brackets. As usual, you don't need to put the name of the ID field, but instead list last name, first name, department, date license, and email which you previously added in the challenge. For the values, indicate the name of the first driver, thus Paula, the first name Erika, in the order of the previous enumeration, hence the department where she resides, 27, her license date between quote and in the day, month, year French format, and then her email address. Separate this query with the next one by a comma. We'll speed up the video for the other values. It is irrelevant to cover them. However, make it clear that each string is surrounded by quote or double quote. On the other hand, it is useless to do so for integers. End the query with a semicolon. As usual, select the query and execute it. Confirm as usual that the data has been inserted with select all from the table's name, in this case drivers. Execute the query and you can see that all 7 drivers have been included in your table and the IDs have been incremented automatically. Let's move on to the next task, inserting data into the cars table. So type insert into the table's name and in brackets the name of each field excluding the ID column. brand, model, year, and driver ID, which will link this table to the driver ID one. Enter the values between quote or double quote, so Renault, Clio, and without quote the year and driver ID, since these are integers. The rest of the queries will be sped up. Separate each one with a comma and finish with a semicolon. Select everything and execute the query which is successfully executed. Check with Select All from Cars. Execute the query and the 6 cars have been inserted into your cars table and the IDs have been automatically incremented. Let's start the new task, changing the year of the Ford Mustang, initially 2000. So enter update the name of the table, so cars. Then set the name of the concerned column, year, equals the new data, so 2010. Where, and then indicate, for example, ID equals 4, since this is a Ford Mustang's ID. Select the query, execute it, and then check with Select All from Cars, and you can see that the year has changed for the Ford Mustang to 2010. Perfect. Let's move on to the final task, which is deleting Remy Oberti. You need to type delete from the driver's table, where name equals Oberti, but you could have also used Remy's ID. Select the query, execute it, and it successfully returns. So type select all from drivers to check that Remy has been removed from the table. And indeed, Remy is no longer part of the drivers table. Good job to everybody! Congratulations! You have completed the data manipulation language section. Let's have a look at what you have learned. You have learned to insert data into a table. You now know how to modify, update, and delete them. You have been able to insert data into your films database, which you will be able to use throughout the whole course. So now, see you in the next section. Welcome to this new section on data recovery using selection queries. In this section, you will learn how to retrieve data from a table using selection queries. To do so, you will use the database you have created in the previous section. You will also learn how to use the where condition and logical operators to filter your results. You will learn how to use in, like, and between in your queries. Then you will learn how to sort and limit data and how to retrieve specific data in your tables. Then you will see how to deal with null values in your tables. Next, you will learn how to set aliases to your columns and concatenate in SQL. Like the previous sections, you will be given challenges and an answer video to test what you have learned in this section. So let's start with data recovery in the next video. you have created your films database and inserted data into it, you'll be now learning how to select data in your tables. So first, select your films database. Here, right-click and click on the Query tool, Éditeur de requêtes in French. Here you will be able to make your selection queries. You have already learned that to select all columns and data in a table, you must use select all from, for example, directors. So execute the query, and here are all the directors displayed. This is the most basic query. Now you will see an example of how you can select a single column from a table. To do this, all you have to do is select the first name column, for example, from directors. Execute the query, and here is the column first name with all the directors' first names. You can also select several columns in a single select query. For example, select first name column, comma to separate the columns, for example the name, and from directors. Execute the query, and you have the first name and name columns with all rows of data from the directors table. You can do it with 3, 4, or even more columns and separate them each time with a comma. This is the most basic select query you can run to retrieve data from a table. In the next few videos, you will learn about other queries which will be more complex. Hello, in this video you will learn how to select data in a table and filter with the where condition. You have already seen the where condition in the data modification. Now you will use it to select the data. So here is the syntax to use. Type select all from the table's name, where the column's name is equal to a given value, so between single quotes. Be sure to indicate the value between single quotes in PostgreSQL. So the idea is to find a specific value in a particular column in a specific table. You will work in the films database and the films table. You will type select all from films and display first of the whole table. You can now apply the where condition to select specific data. For example, you would type select all from films, where select the country column equals Japan. You wish to choose among the films whose country is Japan. Select the query, execute it, and indeed your table only displays films from Japan. You can also set two conditions for a selection query. For example, select all from films, then where, keep the country, and Japan. And for this condition, add director ID and 21. Do not use quotes here since it is an integer. Run the query, and indeed the table displays the films whose country is Japan and whose director ID is 21. If you go back to this query and make a small change, so instead of and type or and change director ID to 1, let's see what it looks like. You can see that the table does indeed display the films whose country is Japan. But you also have a particular row because of the director ID 1 that you added to the OR condition. So, entering a where condition with an AND condition means that the selection query must include both conditions. On the other hand, specifying a selection query with the where condition and another with the OR condition means that you must retrieve a selection with the where condition, but also with a selection with the OR condition. Now you'll see a query with three conditions. So type select all from films, where, this time choose USA for the country, and the director ID is equal to 17. Add a final AND condition for your selection. Choose the length of the film, which is equal to 150 minutes. Run the query and find your table, which has selected a film whose country of origin is the United States, whose director ID is 17, and whose length is 150 minutes. You have now seen the selection queries with the where condition. In the next video, you will learn about logical operators. Hello, you have seen so far the where condition linked to a column equal to a specific value. But you can also use logical operators such as greater than, less than, greater than or equal to, and less than or equal to. So you can have a value greater or less than for your where condition. So let's start with select title and time from films to display the two concerned columns. Here is the list of your films and their running time. Now let's say you want to select films with a running time greater than 2 hours. Repeat the same query and add where time is greater than 120. Select the query, run it, and you can see all the films whose running time is greater than 120 minutes. You can also add the equal sign for greater than or equal to 120 minutes. Run the query and you can find the films over 120 minutes and Spirited Away or The Wizard of Oz, which last 120 minutes, for examples. You can also do the contrary and put less than or equal to 120 minutes, and as you might expect, you'll get all films that are less than 2 hours long. You can also add the equal sign here to get the same films as earlier that last 120 minutes, Spirited Away and The Wizard of Oz. You can see that using logical operators on integers for data selection can be very useful. But note that you can also use them on dates. For example, if you type select all from films, your whole table is displayed and you have the release date column to work with. Type select all from films where release date is greater than the 1st of December 1999, since you'll be selecting films released during the 21st century. Notice the dates in this table are in English format. Run the query and you have all films from the 1st of January 2000 onwards. You can of course put the opposite sign, so less than the 1st of December 1999, and you will have all films of the 20th century. You could have also added the equal sign if you had a film released on the 31st of December 1999, which is not the current case. Logic would suggest that logical operators should only be used on integers or dates. So let's see what happens if, for example, you enter select all from films where country is greater than the United States. You can see that the query has been successfully executed. Indeed, the query was performed in alphabetical order, so the countries with a letter after E have been selected in alphabetical order. Of course, using the reverse sign will retrieve the countries whose letter is before the E in alphabetical order. Similarly, you can add equal to include United States in your selection. Using logical operators on strings is not very relevant, but now you know that it is possible and that they will perform using alphabetical order. Now that you know how to use selection queries, where conditions, and logical operators, let's get to the challenge in the next video. It's time for the challenge. First, you will make a selection query to display all films titles and release dates. Then you will select the name and the first name of all directors whose nationality is British. Next, you will make a selection query to display all female actresses born after the 1st of January 1970. Finally, you will select the title of all films longer than 90 minutes and whose country of production is the United States. It's up to you. Here are the solutions to the challenge. First is selecting all films titles and release dates. You will enter Select All from Films to display the table. Here are the title and release date columns. So you just need to type select title, release date from films. Run the query and you have the two columns displayed. The following exercise involves displaying the first and last names of all directors whose nationality is British. So enter Select All from Directors to display all directors in the first instance. This query is not mandatory, but it allows you to have the whole table shown in front of you. So there are the first name, last name, and nationality columns. First, you wish to display the first and last names of the directors. So type select last name, first name from directors, and put in the condition, which is British nationality. Set the condition where nationality equal between simple quotes, British. Select the query and here are the first and last names of your British directors. Let's move on to the next exercise, which involves displaying every female actor born after the 1st of January 1970. Once again, type select all from actors to display the entire actors table. What you have to look at here is civility, as this will be your condition. So F for female and M for male. Enter select all from actors and add your condition where with the civility equal F. A second condition is the birth date, which must be after the 1st of January 1970, so greater than. So add your second condition and birth date greater than between quotes 1970 01 01, since dates are put between quotes. You have also seen that the dates in this table are in English format, so don't forget to set them in this format. Run the query and you can see every woman born after the 1st of January 1970. The fourth task involves selecting the title of all films longer than 90 minutes and whose country of origin is the United States. So enter select all from films again. No need to display the table, you already know it very well. Your where condition with the running time must be greater than 90 minutes. Do not put between quotes as it is an integer. Your second condition is the country, which is equal to the United States. Run the query and you get all films from the United States that are longer than 90 minutes. So here are the solutions to this challenge. Well done if you have managed to do this challenge without help. Don't worry if you failed. You will eventually get the hang of it. Hello, up to now you have seen how to select data in tables in which the column is equal to a specific value. In this video, you will see how to select data for columns equal to more than one value. Let's select some data from the actors table. Type select first name, last name from actors, where first name equal Bruce. So logically, you have selected all Bruces from your actors table. Indeed, Bruce Lee and Bruce Willis. Now let's see what happens if you select the first and last names of an actor named Bruce or John. So, select first name, last name from actors, where first name could be Bruce, then John. Select the query, but you can see that it returns an error. In this case, you need to use the in condition instead of equal. So replace the equal with in and put the rest between brackets. Select the query. Indeed, you can find the Johns and the Bruces. In other words, you select the column in which the values can be found. You can add as many values as possible by separating them with a comma. For example, if I copy and paste this same query but add the name Peter to it, it will return the Johns, the Bruces, and the Peters. You can select data that do not have certain values, thus excluding this or that actor. To do so, pick the same selection, paste it, and put not in instead of in. Let's see what happens. Here is the actors table, but neither John, Peter, nor Bruce can be found in the list. You can also perform in and not in queries with integers. Let's try with IDs, for example. Select actors ID. You'll select the first and last names from the actors table. Where actors ID, you'll select several of them, in, and add 1, 2, 3, 4, and 5. Of course, no quotes since these are integers. Run the query, and here you have the 5 actors with the IDs from 1 to 5. Let's do the same with the not in condition. Logically, you have all but the first 5 actors with the first 5 IDs. You have learned to perform a select query with several reference values, using in and not in. In the next video, you will study the like condition. Hello, in this video, you'll see how to use a like operator followed by the percent sign and the underscore sign. Earlier in this section, you studied the case where the column equals a specific value. But what if you just wanted the column value to contain a particular character? Let's say you want to select all actors with the first name starting with P, for example. To do so, use the like operator and put your character symbol between simple quotes. Of course, start with select all from actors, where first name like. Open the quotes, put first a P, then the percent sign. Finally, close the query with a semicolon. The percent sign replaces unidentified characters. There can be one or several characters even known instead of the percent. So this query will retrieve all values starting with P in the first name column. Run the query and you get all actors whose first name starts with a P, like Peter, Pepe, Paddy, and so on. You can also see that the number of characters after the P is not defined or limited. For example, you have Per with 2 characters or Patrick with 6. Indeed, the percent sign looks for what is after the character symbol, regardless of the number, unlike the underscore. The underscore searches for a single character where it is located. So let's see what happens if you replace the percent with an underscore. Run the query and indeed you get no results. As you have just seen, there is no first name that has only one character after the P. However, if you add an E after the P and run the query, you can find the first name Per with the last name Ragnar, which you saw earlier. So you can use the like operator for sample recognition, and the percent sign will search for an undefined number of characters. As for the underscore, it will search for a single character. This is not the only possible scenario. The signs can also be placed before a character. For example, pick the first select query and replace it with percent and R. You will be looking for first names ending with an R, regardless of how many characters precede R. Run the query and you can see all first names ending with an R in the actors table. Now add a percent after the R. You will look for a first name including the letter R with an undefined number of characters before and after. Run the query and you can see a significant number of return values since these are all first names including before and after an R, an undefined number of characters which can even be 0. Indeed, the query considers the fact that there may not be any characters instead of the percent. So this is why it includes Peter even though there are no characters after the R. You also have Hiroki, Clark, Carla, Daryl or Rutger. Nothing prevents you from adding as many characters as possible between the percent signs. For example, let's add an L after the R. After running the query, you can see Marlon, Darlan or Carla, each with a different number of characters before or after the R and L. You can do the same thing with the underscore. Pick the same query and instead of the percent, put some underscores. If you run the query, it won't return any result. But if you add another underscore before the first one, meaning 2 unique characters before the R and L, and 1 after, it will return Carla. So you have seen how to use the like operator to use sample recognition. Percent signs are for an undefined number of characters which can even be 0, and underscore signs for a single and unique character. Hello, in this video you will learn how to select data whose value is in a specific interval. For example, you will select films released in a given period. Let's start with typing select all from films to display the whole table. Select, run the query, and all films are displayed. Here is a release date column. Let's say you want to select films released between the 1st of January 1995 and the 31st of December 1999, or a period of 4 years. Type select title from films. You will display the title and the release date. Where, release date, between, and insert your dates, so the 1st of January 1995 and the 31st of December 1999. Don't forget that the dates in this table are in English format. So between and are the necessary operators to create an interval. Select the query. Indeed, you have the 6 films included between the 1st of January 1995 and the 31st of December 1999. The between operator is not limited to dates. It can also be used for intervals in integers. If you select the whole films table again, you can see that the time column displays the film's running time in minutes with integer values. For example, select the films lasting between 90 and 120 minutes. Enter select title, time from films, where time between 90 and 120. Since these are integers, do not put them between quotes. Run the query and you have all films with a running time between 90 and 120 minutes. But the between operator is not limited to integers and dates. It can also be used for strings like the varchars. Type again, select all from films to display the whole table. For example, you have the country column with a varchar data type. You will select a list of films whose country is included between the letter J and S in alphabetical order. Enter select title, country from films, where country between J and S. Select the query, execute it, and indeed, the query has returned every film included between the letters J and S, like the US, Japan, and Spain. Indeed, Korean starts with a K, so it is included between J and S. For example, if you wish to exclude Japan from the list, add a lowercase e after J. Then run the query and you can see all films between JE and S. You can add as many letters as you want, even an entire word, to delimit the between operators interval. So this is how you use the between operator to select one or several values included in a given interval, whether numerical or alphabetical. It's time for the challenge. First, you will select the title and country of films whose country of origin is the US, Spain, or Korea. Then you will select the last and first names of actors whose last names start with M and were born between the 1st of January 1940 and the 31st of December 1969. Finally, you will select the last and first names of directors with a Chinese, Brazilian, or British nationality. It's up to you. Hello, here are the solutions to the challenge. First, you have to select the title and country of films whose country of origin is the US, Spain, or Korea. Type select title, country from films, where country in, add each country between brackets and quotes. So here, US, Spain, and Korea. Always end with a semicolon. Run the query, and you have here all films whose country of origin is the US, Korea, or Spain. For the second exercise, you have to select the last and first names of actors whose last names start with M and were born between the 1st of January 1940 and the 31st of December 1969. Type select last name, first name from actors, where last name, like, add between quotes the capital M and the percent sign. And birth date between, and add here the dates in English format, with N to mark the interval. Run the query, and you have all actors with the last name starting with M who were born between the 1st of January 1940 and the 31st of December 1969. The third exercise involves selecting the last and first names of directors with a Chinese, Brazilian, or British nationality. Type select last name, first name from directors, where nationality in, and add the nationalities between brackets and quotes. So Chinese, Brazilian, and British. Be careful to add the capital letters like in the table. And with a semicolon, execute the query, and you have all Chinese, Brazilian, and British directors. Well done to everybody. Even those who didn't succeed, you still tried. Congratulations, and see you in the next video.